In example 4, we're going to look at the change of base property. Okay, and the change of base property takes a log of a given base b of the argument m, and it changes it into a ratio of logs of any base. So the r here could be anything. It could be a 10, which would be common logs. It could be a base of e, which would be natural logs. It could be a base of 50. Any base at all you can use for the r. So we take the log base b of m, and that's equivalent to the log base r of m divided by the log base r of b. So if I want to use a calculator to approximate the log base 7 of 21 using common logs are base 10. So this log base 7 of 21, I would use the change of base property with common logs. So the common log of the argument divided by the common log of the base. And then in the calculator, we're going to use our log button to evaluate that expression. So we'll take the log of the argument divided by the log of the base, and we get approximately, rounding to 4 decimal places, 1.5646. Okay, now if instead of common logs, right, which are base of 10, if I wanted to evaluate that using natural logs, I should get the same answer because the r, remember, can be any base. So with a natural log, we're going to have the natural log of the argument divided by the natural log of the base. And when we put that into the calculator, natural log of 21 divided by natural log of 7, notice we get the same thing, right? 1.5646. Okay, so now in example B, we're asked to rewrite each as an approximation of 1 log rounded to 4 decimal places. So we've got a ratio of natural logs here, the natural log of 20 divided by the natural log of 3. So to write that as 1 log, we would condense that using the change of base property as a log base 3, because the 3 is the argument in the denominator, of 20, because that's the argument from the numerator, and then that is approximately equal to 2.7268. 2.7268, rounding to 4 decimal places. Okay, then in the next one, we have the common log of 5 divided by the common log of 15. So we can condense that using the change of base property as the log base 15, because the 15 is the argument in the denominator, of 5, that's our argument from the numerator, is approximately equal to, and then we'll round this to 4 decimal places to get 0.5943. So the log base 15 of 5 is approximately 0.5943. Okay, so on some scratch paper, if you'd like to go ahead and try A, B, and C. In A, you're going to approximate the log base 8 of 16 using a ratio of logarithms. So that would be your change of base property. You'll need a calculator to get an approximation. Then in B, you're going to look at the work that's given here and rewrite this as 1 log. And then explain in C what is the relationship between the log base 8 of 16 and the log base 16 of 8. Okay, so example A, the log of 16 divided by the log of 8 is approximately 1.3333 rounded to 4 decimal places. You could also have done that with natural logs instead. So the natural log of 16 divided by the natural log of 8 also gets you the same 1.3333 repeating. And in your calculator, if you type in that decimal, 1.3333 repeating, and then press math, and number 1 is fraction. That's going to take our answer and turn it into a fraction, and that's exactly equal to 4/3. So we know that this is exactly 4/3, or approximately 1.3333 if we're rounding to 4 decimal places. Okay, then in example B, the natural log of 8 divided by the natural log of 16 would be a log base 16 of 8, and that's equal to 0.75. And if we put 0.75 in the calculator and change that to a fraction, we get exactly 3/4. So if the log base 8 of 16, that is 4/3. Log base 8 of 16 is 4/3. And the log base 16 of 8, that is 3/4. Then what is the relationship when you exchange the argument and the base of the logarithm? So notice the base and the argument here switch places. 4/3 and 3/4 are reciprocals. So they are reciprocals when you exchange the base and the argument of the log.